So about 2 years ago, Starknet Alpha was released, and along with it came this very esoteric language called Cairo. It was a really terrible language to write anything in, but it had this very interesting property that it was provable. And being a provable language opened up, a lot of things in people's imaginations of like what would be possible in the future. And one of those people was Parama, who came to the Dope Wars Discord, which is an on-chain gaming ecosystem we started about 2 years ago, and made the proposal to build a recreation of the classic game Drug Wars on top of Starknet in Cairo. And it sounded like a great idea, so we kind of started going down that rabbit hole. And alongside that, there was someone by the name of Guilty Goiza, who you guys might know from Topology, who's been doing a bunch of interesting gaming experiences on Starknet, and has Shaoxin. If you haven't heard of that one or you haven't seen that, you guys should definitely check it out. That he's just, I think they're playtesting it tomorrow. And he started, 2 years ago doing interesting things on top of Starknet, trying to just like expand the imagination of developers of what kind of things can you do on a blockchain now that you have these new affordances of basically like a lot more compute available. But at the time, these promises were not realities, and the Starknet ecosystem in its immaturity was really kludgy to work with. But despite that, there was a bunch of teams trying to build interesting games. One of the examples is Dope Wars and the Realms team, and Topology, Influence, and Brick. And a lot of these teams actually came from the EVM world. They were initially trying to build their games in Solidity and started running into a lot of the limitations of building complex applications in Solidity. And I'm sure if you guys have spent a lot of time developing with Solidity, you've run into stack too deep errors or contract size errors, where you have to basically refactor your entire application and decompose it into a whole bunch of different contracts. And it's just like the Solidity itself was designed to build very simple financial applications, and now we have these new affordances that weren't part of the requirements of the language, and it doesn't fit neatly into the existing language. And to be fair, it's improving in a lot of dimensions. This brings us to where we are today. So in the last 6 months in the Starknet ecosystem, we've made a tremendous amount of progress in a bunch of dimensions that has enabled us to finally start achieving this goal of fully on-chain games on top of Starknet, and fractal scaling and layer 3s and instance-specific rollups or battle servers, and all these kind of things are ready for market basically today, right? If not in the next 6 months or so. So I'm going to walk through a few of the different pieces that have enabled this on top of Starknet today. The first on the Starknet side is the introduction of Cairo 1 about 6 months ago. Cairo 1 is a new language that is much higher level than the original Cairo implementation. It still has the provable property, but it's much more Rust-like in syntax and very and composable, and is well suited for building very complex on-chain applications like games. The second is this upgrade to Starknet that is called More TPS Daddy. This is the symbol. It's kind of a meme in the Starknet ecosystem, but you guys might be a little bit outside of the echo chamber. But basically, it was the result of an effort by an external team called Lambda Class, who re-implemented the Cairo VM in Rust entirely, which increased the performance of it by 10 to 50x in certain regards, which obviously was a massive unlock for what we're trying to do with on-chain games. And there's some interesting further improvements on this that will land in the next few months. One of them being Cairo native. I'll just mention because for context for you guys, where you can compile Sierra, which is the intermediate representation of Cairo, directly to run natively on hardware, like to LLVM, for example. And it's going to be an additional 10 to 100x performance improvement over running inside of the Cairo virtual machine. And then the third here on the Starknet stack side of things is Madara, which is a layer 3 sequencer. It's built on top of the substrate platform that Polkadot has developed. And it's basically a layer 3 sequencer that you can fully parameterize yourself. You can run on top of Starknet. You can have very short block times. You can have configure the gas pricing however you would like. And there's a whole lot of new configurations that are possible with this on top of Starknet layer 2, and with this additional level of aggregation, you get significantly lower fees too. Another piece of the puzzle has been the Dojo ecosystem that we started developing around 6 months ago. So Starkware went through the transition period of translating all the existing implementation of games in Cairo 0 to Cairo 1. A bunch of us in the ecosystem that have been building games for a while came together and said, look, this is a great opportunity for us to take all of our shared learnings from the past of building games in Cairo 0, coordinate into building Dojo, which is a tooling on-chain provable game engine and toolkit for developing games, like kind of the horizontal requirements of a lot of the games building the ecosystem, something that's quite similar to Mud, if you guys are familiar with that, for games building on top of Starknet. So we build out the Dojo ecosystem. Dojo itself is a language in the ECS framework. It provides a tool chain. One of the tools being Sozo, which is a world migration toolkit or tool chain for basically making it simple to define games and then to deploy them into the world and then allow people to easily extend them. Katana, which is a high performance developer sequencer that enables like things like battle servers in the future and significantly improves the development experience. And then Torii, which is basically tasked with translating the data that's on chain into an easily consumable format for like whatever client you're using. So if you're rendering with Unity, Unreal, Bevy, or one of these frameworks, you need basically reactive bindings down to the blockchain so you can update the client to reflect the current on-chain state. And Torii, this is the responsibility of Torii. And the last piece of the puzzle is Cartridge. Cartridge, I'm one of the co-founders of Cartridge. We started Cartridge about 1.5 years ago after this realization that it's trying to build roll your own in the initial Cairo for the Dope Wars ecosystem, and recognizing like the potential of on-chain games, but also a lot of the gaps that needed to be closed to make these possible in a way that's a great user experience that developers can actually build them and that players want to actually play them. And so the focuses of Cartridge is one is accelerating the development cycle of building these games. So we're working on, the last 6 months has been focused primarily on Dojo, of just helping people build games locally. The next 6 months is going to be focused on like allowing developers to take games that they built locally and execute them in a shared context, easily deploy them to sequencers, to test with your friends, to run play testing, tear them down, pull them up, and manage all of the infrastructure that's necessary to build like high throughput, real-time applications on top of Starknet without all of the overhead that you typically have to do on the DevOps side. The other is Explorer, that is a product we're going to be announcing in the next few months, which is basically like a on-chain blockchain explorer, but contextualized to on-chain worlds. So instead of blocks and transactions, you have like entities and components and systems, and you have like a much more contextual understanding of the history of a world, and as well as like a generic interface for interfacing with it for reading the information from the world and potentially extending it. And then Play, one of the first things we built out was a Cartridge controller, which is just around like interactions with games, making these very easily to do, removing, like transaction confirmations and the need to install extensions to build games, and making wallets and stuff available or signers available inside of games. There's something that we put on the back burner for the last couple months as we've been trying to build like bottoms up rather than from the top of the funnel, but something we'll potentially come back to. And that all comes together to form basically the Starknet stack for on-chain gaming. These are the tools that you can use today to build games, like compelling games, complex games, fully on-chain that take advantage of this property of provability, cheap compute that Starknet makes available. You can deploy them to layer 2s, layer 3s, whatever you want. And you can do that today. And so this brings me back to the Dope Wars, which we started building 2 years ago, which today we have available for playtesting, the initial version of the game, built entirely of this stack that I just described to you, deployed to a Madara instance, built with Dojo by the Cartridge team. So you can check that out if you're interested. And so this is, in this diagram, is deployed as a layer 3 on a Madara game-specific rollup. So the question is, what's next? So the last couple weeks, we partnered with a few teams in the Starknet ecosystem, and this is, the autonomous agents part of it. We partnered with a few teams in the Starknet ecosystem to build this game called Drive AI. And Drive AI is a permutation of the original Road Fighter game, and it's a collaborative work by Cartridge, Giza, and the Starkware Explorations team. The game looks a little bit like this. Basically, it's a fully on-chain 2D physics engine that simulates this driving game. And in the classical game, you would drive the car with the D-pad. But in this new version of the game, you train a neural network off-chain to drive the car. And I'll show you a little bit of a video of what that looks like. Let's see if this will play. I think I have it locally here. So it looks a little bit like this. So the cars themselves get, a bunch of sensors in front of them. The on-chain physics engine computes like whether they're intersecting with walls or have collided with another car. These rays that are projected out of the car provide information to the neural network of where they're intersecting with objects on the map. And on the left, you can see like the leftmost column, you can see the ray inputs to the neural network. You can see like the hidden screen, and then the output of the neural network, which is basically a prediction to turn left or turn right. And so the idea here is like really pushing the limits of what is possible with these new affordances of the Cairo VM and its performance. And with this idea of a provable game engine, what can you do? So in this case, basically what you can do is you can build a game where you can run a simulation off-chain. You can train like kind of on in your own environment a neural network that can be a black box. It just like takes this input and produces this output. The intermediary layers or like the architecture of the neural network is up to you. You can train a neural network, and then you can benchmark it against like the current best scores in the network in the world, and you can prove that output. So if you build a neural network, you run inference with this provable game engine, and you achieve a top score, you could decide, okay, I want to prove the output of this, and then you can settle that proof onto the layer below, onto like a public context of the blockchain, and you can convince everyone that you have a model that achieved this score in this game without ever exposing that model to them, and without having to do all this execution in the shared context of the blockchain, because like this is something that doesn't need to be done in a like kind of zero-sum environment. So this game itself took, in Cairo you measure performance in steps, and a lot of blockchains are more about transactions per second. Doesn't quite translate to the Cairo VM. So at 700 steps is quite a significant number of computations to be able to do per second. We have the repo open source if you want to check it out at Cartridge-GG Drive AI. And just a shout out to some of the people that we built this with: Carrie, Jun, Lucas, Danilo, Stu, Raphael, and myself. And yeah, so this is a kind of an experimentation with, a lot of people here have talked about like battle servers, or just this idea of doing off-chain computation, and particularly like the property that you need is provability. And in this case, it's taking advantage of a similar architecture where you have like this instance or dungeon-specific roll-up that's like just for this off-chain piece of the game that you settle onto a lower layer later. Cool. And so that's a little bit of a speed run of the history of on-chain games and Starknet and some of the interesting experiments that we're doing. And yeah, hope it was interesting, and happy to answer any questions.